Kia ora, year 11 and 12. This is a video for class tomorrow, June 25th, and it's going to go over the vectors material that goes with exercise 10C. And again, it's a review of stuff that you did in AS. We're going to look more closely at how to find the angle between two lines. I'm going to do an easier example than a harder example. Now, I've had big computer trouble tonight. Windows Update has updated for no reason. I didn't ask it to. So everything about how I record these has gone wrong. So if you could give me some kind and gentle feedback about whether the sound quality is okay and whether the pen is okay, because it started doing some really annoying things. For example, this. So let's look at my basic definition of the angle between two lines. Now here, I'm just working in two dimensions, and I've got a vertex where the two lines meet, right? This one here is vector B, and this one here is vector A. The angle between them we're going to define as theta. Now, hopefully you remember that we had this. Cosine of theta is equal to the dot product, A dot B, divided by the magnitude of the two vectors. Okay, so a really important thing to notice here for when we get to our harder problem is that I have looked at my vertex and then I've taken the vector going away from that vertex and the other vector going away from that vertex. One place that things can go wrong is if I have the vertex, let's make the vertex here, and I define the vectors going towards it. Okay, so I just find it easier to think about starting here and then going out from each. Right, now I've drawn the same thing 3 times over. Okay, so first I'm going to do an example to jog your memories about the dot product and the magnitudes, and then I'm going to do question 6 out of 10C. Now if you don't want to watch the video, the worked solutions are up on Google Classroom and they go through it in detail, but for most of you I think watching the video might help a wee bit. So let's just start with two vectors. This one, the angle between this vector and this vector. So this is the one straight out of the book. You can think of these as two direction vectors, right? So they're part of a line, and the line might be something like this. So say we start at point 1, 1, 1, and then we've got this. So that's the equation of a line. And then the second one, we'll make it R1 and R2, might come from the point 2, negative 1, 17, plus mu times 2, negative 1, 3. So how come I'm just interested in the direction vectors when I do that? Well, this is the bit where you're going to have to pick up 2 pens in front of you, because I'm not going to be there tomorrow to do the 2 pens routine. And I want you to try and draw 2 skew lines that don't meet. Right, so you're going to have one line going kind of like this in one plane, and then another one underneath it, but not meeting, right? So think of this one as the high up one, and this is the low down one. So they're in different planes. How does it make sense to talk about the angle between these two direction vectors? Well, you can still kind of visualize it, right? But what you've got to do is to pull one of those lines up so that they do intersect, and then you're going to get theta like this. Now, if that makes no sense, get someone next to you to wave the 2 pens around in the air and then try it. And if not, I promise I'll do that on Friday this week. Right, but what we're focusing on is that we can basically force these two direction vectors to meet by moving around the starting point. And then we can think about the angle between those 2 points. So how do we do it here? Well, we've got these direction vectors. So we might as well start by finding their magnitudes. Right, so we'll call this one A and this one B. So the magnitude of A is equal to 16 plus 9 plus 0, the square root of all that. So that's the square root of 25, which is 5. And then the magnitude of B is the square root of 4 plus 1 plus 9, which is the square root of 14. Right, so the angle formed here might be something like this, or it might be more like this. Okay, and in this case we're going to find that it's obtuse because we end up getting a negative number in here. So we've got cos of theta is equal to A dot B over 5 root 14. And that dot product works out to be, so remember the vectors were these. We've got 2, negative 1 and 3. So that's going to be negative 4 times 2 plus 3 times negative 1 plus 0 times 3. Probably time I changed that pen. There we go, and it's going to be 5 root 14. So the numerator gives me negative 8 minus 21. No, it doesn't. That's a 1. Can't read my own pen. Minus 3 over 5 root 14. So theta is equal to cos inverse of negative 11 over 5 root 14. So if you chuck that into your calculator, you get theta is equal to 126 degrees. Okay, so that's the first straightforward example. Now, how do I check if two vectors are perpendicular? Well, we've already looked at this, and we know from trig that cosine of pi on 2 is 0. So if I find that the dot product works out to be 0, then I've found that the two vectors are perpendicular. But now what I want to do is to move on to question 6 in exercise 10c, which is on page 243. To do question 6, you need to have a look at the book because it's got a lovely diagram of a house. So I'm going to try and draw the house here. So here's the house. It's got a front face like that, and then it's got a triangular roof, but the triangular roof is sloping backwards. Now, typically when we've got a problem like this, we're going to mark one of the vertices in 3D as the origin, and then we'll define everything with respect to that. And if you work slowly through it, it shouldn't be too hard. You can think of this dimension as being the x dimension. The vertical one is the z dimension. So this point up here, this is point E, and this is 0, 0, 3. So the only thing that's changed from here, where I'm wiggling the pen, up to here, is that we've gone up. At point F out here, the x has changed, so this point A here, let's see what this has got. Well, I have to use some other information for that one. So let's try, I'm going to try and badly draw the rest of this house. So there's this. So those two make the bottom floor of the house. And then we're going to draw that wall up there like that. How are we doing? Oh, this actually looks kind of okay. Right. Okay, you guys know what my drawing's like. There we go. Huh, this is not that bad. There, and that one goes like that. Right, so if you're watching this in class, you might want to get Pablo or Shekinah or someone who can do art to draw that up on the board. Okay, just ask the relieving teacher if they can do that. So here's point F. The first part of the question says work out the coordinates of A and work out the coordinates of F. So how can I figure out F? Well, let's start with A. So here, we don't know the x coordinate, but that's the only one that's changed. So this is going to be 0, and this is going to be 0. This point back here, B, is at 4, 5, and 0. So if you think about the x direction, this 4 here has to match this 4 here. Right? And then here, this y coordinate of 5 has got to be matching for that one there. Right, what about the z coordinate for f? So f is going to have coordinates 4 for x, no change for y, but it's gone up. And it's gone up by 3 units. So f is going to be 4, 0, 3. Right, now the next thing we've got to do is we've got to find the angles. Right, so I'm only going to do one of them because they're kind of the same, but we're finding f, the angle FPQ. So the angle that I'm looking for in here is that angle in there. So P is going to be the vertex. So a good diagram here is going to help us not go wrong. Here's P at the vertex, and this point is Q, and this point here is F. Right, so we can write this. Cos of theta is equal to the vector going from P out to F. And we want the dot product of that with P going out to Q. And then we need the magnitudes of those two vectors. So I think that's probably the hardest part, is setting it up. Now then think about what PF and PQ are. Let's see. Where's F, P and Q? Right, so P is the point that we're given. So P is 2, 1, 4. F is 4, 0, 3. And Q is 2, 5, 4. So just be careful, if we're going from P to F, we end at point F, which turned into a column vector is 4, 0, 3, and then we subtract our starting point, which is 2, 1, 4. So that gives me 2, -1, and -1. Then we do the same thing, going from P out to Q. We end up at Q, so that goes first, and we started at P. So that gives me a direction vector of 0, 4, and 0. So we've done all that. I'm going to get the magnitudes, and then we're ready to go. So the magnitude of PF is equal to the square root of 2 squared plus -1 squared plus -1 squared, which gives me the square root of 6. And then the magnitude of PQ is equal to, well, this is easy, 0 squared plus 4 squared plus 0 squared, which is simply 4. So the angle between those two things, there's theta here, is this. The cosine of theta is equal to PF dot PQ divided by 4 root 6. So what do we get for those two? Well, it's this. So it's 0, 4, 0 dot 2, -1, -1 divided by 4 root 6, which gives me -4 over 4 root 6, which is -1 over root 6. So theta is equal to the angle whose cosine is -1 over root 6, and I think that works out to be 114 point something degrees, 114.1 degrees. Okay, so that's kind of a classic example of where you've got to figure out some information for yourself before you do the question. So let's just go back to the start and quickly recap what we did. So we had this bad drawing of a house, right? And we had to figure out the coordinates of this point and the coordinates of this point. So we just work systematically starting from the origin and think about which component is moving. So when we go here, we're going up, so the z is changing, right? When we go out this way, the x is changing, so you'll see 4 and 0 changing there, and so on. So we get the coordinates for F and A, and then we have to find this angle here. The key to doing well with this question is to make sure that this is the vertex, and remember that I've got this vector going in that direction, and this vector going in that direction. And then we apply our formula for the angle between formed by two lines. Alright, thanks for watching. I'm going to do an old exam question in a minute. I just have to try and figure out how to fix up the silly cursor thing on the computer. So feel free to get going on exercise 10.6C if you've got to that point before class.